Hello, my name is Gladys Duran, and I'm a materials engineering senior student at Instituto Tecnológico de Morelia in Mexico. And I'm going to present my project titled Thermal Stability of a Batch Furnace. I developed this research in FEMSA's heat treatment furnace while I was an intern. So, let's start. This is the content of my presentation. I'll start with the objective of this research, a brief introduction to the topic. Then I will explain the experimental procedure, the results, and final conclusions. Okay, the aim of this work is to demonstrate the thermal homogenization inside the batch furnace. But before moving forward, let's make clear some terms used in this work. We must be on the same page. I mean, we are in the heat treatment field, but what is that? Well, according to ASM, it can be defined as a series of time-temperature treatments. But I really like to see a heat treatment like a controlled process of heating, including materials to modify their properties. So, with this simple concept, we can understand the impact of the thermal stability inside the furnace. It must be controlled to obtain thermal homogenization during the process and obtain the mechanical properties according to the final application. In other words, thermal homogenization is the key to quality improvement and also cost reduction for the company. I know, heat treatment is a whole world. There are many furnaces that can be used for this process, but we will focus this research in a batch furnace, that is a furnace that processes one load at a time and looks like this. Okay, but in order to make a mathematical simulation of the convective flux, the furnace was measured and all the relevant information related to fuel burners, airflow, and working zone was used for that simulation. These are the measurements of the furnace in meters and the position of the burners inside it. And to obtain the temperature profile data, an experiment was performed in the furnace to increase the temperature to 4 different set points using 2, 3, and 4 burners to 200, 500, 900, and 1100 Celsius degrees, and based on the graph to determine the temperature gap. We used 4 thermocouples type K to measure the temperature, and this is their position inside the furnace. This. Okay, we have on the figure on the left, this is the results of the simulation in which we observed turbulence flow when 4 burners were on. With this, we also determined the hotspots in the furnace, and based on the experiment, we found the temperature gap in low temperatures. It takes longer to stabilize on that set points, as you can see in the graph. And finally, at the end of this research, we reinforce the importance to know heat treatment furnace behavior to determine the correct working zone, avoiding hotspots or high turbulent flow. And also we can conclude that thermal stability can be controlled using the correct number of burners depending on the temperature to reach in the airflow. So for this case of study, the recommendation is to use 3 burners from 500 to 900 Celsius degrees to reach the best thermal stability. These are some references used for this study. Thank you so much for your attention.